In this video, we will find the intersection of a curve and a surface. So here our curve is a helix, given by this vector equation, and the surface is a sphere, given by the standard equation x squared plus y squared plus c squared equals a constant. And so we are to find where they intersect. In part A, we find the value of t from the vector function where they intersect, and then in part B we're supposed to find the actual coordinates of the point where that intersection is. So okay, first let's do part A. Now here's the idea. We look at the vector equation for the curve. So here's our x component, and then here's our y component, and here is the z component. Now the idea is to just take these three component functions and plug them in for x, y, and z into the equation for the surface. In this case, the surface is the sphere. So here we have x squared plus y squared plus z squared equals 5. So for x, y, and z, let's just plug in our three things. So here we have x squared is going to be sine of t squared. Y squared is going to be cosine of t squared. And z squared is going to be 4t, the whole quantity squared. So that's 16t squared. And that should be equal to 5. And of course we can simplify this. Sine squared plus cosine squared is of course 1. And at this point it just becomes a simple exercise in algebra. So we just shuffle things around. Subtract 1. Divide by 16. Get a quarter. And so we easily see now that t is either 1/2 or minus 1/2. So there are two solutions to part A. So here's our answer to part A. We have two answers. The helix intersects the sphere both when t is 1/2 and when t is negative 1/2. Now part B is very easy, knowing the answer to part A. To find the coordinates of this point, just plug in 1/2 and negative 1/2 into the original vector function r. So we just plug in 1/2, and we get sine of 1/2, cosine of 1/2, and 4 times 1/2, which is just 2. And then similarly for negative 1/2. To find the other point of intersection, we just plug in negative 1/2 everywhere. So sine of negative 1/2, cosine of negative 1/2, and negative 2. And there we have it. Those are the two points of intersection.